Welcome back. I know the second video for the day, it would be a heavy burden on you, but I felt it will be nice for you to solve the same type of problem in continuity so that it will be easy for you to learn as well. So I thought I'll do the second video also today itself. So the second or the next type of problem that we would be dealing with is a balanced maximization assignment problem. First, we saw balanced minimization case. Then we saw unbalanced minimization case. Now we are seeing balanced maximization case. So how do we identify the maximization case problem? When the objective of the given problem is to maximize the profit, right? Now we are not dealing with cost. We're dealing in terms of profit. So people would be interested in reducing the cost. But when it comes to profit, no one wants to reduce profit. They want to increase the profit. That is maximization, right? So if the variable, decision variable in the objective is for maximization, then the problem is said to be maximization case. If the problem is maximization, then we don't have a direct solution for it. It has to be converted into a minimization case problem because the algorithm that we have defined, that is the Hungarian method, solves only balanced minimization problems. So now whatever maximization problem is given, we will have to convert it to minimization and only then we will be able to solve. So how to convert maximization to minimization, that we'll see now. The profit matrix that has to be converted to a lots matrix by subtracting all the elements of the given profit matrix from the highest element of the given matrix. So what does this mean? From the problem given, identify the biggest value in the entire matrix. Whichever is the biggest value, you are supposed to identify that first. After identifying that, subtract all the other elements of the matrix from that biggest matrix. So whatever was your profit matrix gets converted to loss matrix now. So will you be interested to maximize the loss or minimize the loss? Minimize the loss. So automatically your maximization problem got converted to minimization problem. So for this converted loss matrix, apply the steps of Hungarian method and get the final assignments. For this final assignments, consider the original matrix, that is the profit matrix values, to get the optimal assignment value, your TAC, right? Total assignment cost, whatever we were calculating. In maximization case, we don't call it cost matrix or TAC, we call it optimal assignment value because we are maximizing the profit. So we have understood the procedure now. So we have to understand this procedure better. So let us do one thing. We'll take a problem and try to solve the problem so that we will understand the process better. So what is the problem that we consider? So let me read out the problem. A marketing manager has 5 salesmen and there are 5 sales districts. So 5 men, 5 districts, 5 x 5 matrix. So it is balanced. Considering the capabilities of the salesman and the nature of the districts, the estimates made by the marketing manager for the sales per month for each salesman in each district is as follows. So the variables here, the decision variable here is the amount of sales per month. So as a businessman, will you be interested in minimizing the sales or maximizing the sales? Obviously maximizing the sales. So it is a maximization case problem. So find the assignment of the salesman to the districts that will result in maximum sales. So we have seen that the given problem is a maximization case problem, but it is balanced. So we need not convert it into a balanced problem because the given problem itself is balanced. So the only conversion that I'll have to do is minimization case conversion has to be done. Maximization case problem has to be converted to minimization case problem. So we'll see. So this is the given profit matrix. So in this profit matrix, which is the largest number? 32, 38, 40, 28, 40, 40, 24, 28, 21, 36, 41, 27, 33, 30, 37, 22, 38, 41, 36, 36, 29, 33, 40, 35, 39. So we observe that the maximum value is 41. So what are we supposed to do now? We are supposed to subtract all these values from 41. So 41 minus 32, 9. 41 minus 38, 3. 41 minus 40, 1. 41 minus 28, 13. So every individual value has to be subtracted from the maximum value. That is how this profit matrix gets converted into a loss matrix. So the resultant loss matrix that we have got, we will just have a look. The values are 9, 3, 1, 13, 1, 1, 17, 13, 25, 0, 14, 8, 11, 4, 19, 3, 0, 5, 5, 12, 8, 1, 6, 2. Now check whether all rows have zeros. No, it does not. Does all columns have zeros? No, it does not. So what are we supposed to do? Perform row reduction and column reduction. So we'll go into the row reduction step now. So the minimum of each row has to be taken. So from the first row minimum is 1. From the second row minimum is 1. From the third row minimum is 0. From the fourth row minimum is 0. From the fifth row minimum is 1. So subtract these values. You will get the result as 8, 2, 0, 12, 0, 0, 16, 12, 19, 4, 0, 14, 8, 11, 4, 19, 3, 0, 5, 5, 11, 7, 0, 5, 1. Check whether all columns have zeros. No. Second column and fourth column does not have zeros. So I'll have to perform column reduction. So for column reduction, identify the minimum values. First column minimum is 0, second column minimum is 2, third column minimum is 0, fourth column minimum is 5, fifth column minimum is 0. So subtract these values. The resultant will be 8, 0, 0, 19, 11, 2 minus 2, 0, 16 minus 2, 14, 14 minus 2, 12, 3 minus 2, 1, 7 minus 2, 5. Here it will be 0, 12, 8, 0, 0. Here it will be 12 minus 5, 7, 19 minus 5, 14, 11 minus 5, 6, 5 minus 5, 0, 5 minus 5, 0. Coming to the last column, it will be 0, 4, 4, 5, 1. Right? So the same values I write down and go with the assignments. So the resultant matrix for which assignment has to be done is 8, 0, 0, 7, 0, 0, 14, 12, 14, 4, 0, 12, 8, 6, 4, 19, 1, 0, 0, 5, 11, 5, 0, 0, 1. Okay. Check whether all rows and all columns have zeros. Yes, all rows and all columns have zeros. So straight away go with the assignment. So I go column wise. First column has two zeros. Second column has only one zero. Third column has three zeros. Fourth column has two zeros. Fifth column has only one zero. So column wise I go. First column with minimum number of zeros is second column. So in the second column I find a zero, I make an assignment. I cross the zeros in the same row and same column. So in the first column I am remaining with two zeros. In the third column I am remaining with two zeros. In the fourth column I am remaining with two zeros. Fifth column does not have a zero. So now all have 2 2. So whichever order you want, you can follow. I go column wise. So first column, I find the first zero, I make an assignment, cross off the zeros in the same row, same column. So now I am remaining with two zeros in third column and two zeros in fourth column. So third column, I make a assignment, cross off the zeros in the same row, same column. I'm left out with only one zero in the fourth column, make an assignment. So how many assignments I've got? Four assignments. How many I was supposed to get? Five assignments. So have I arrived at the solution? Not yet. So what I'm supposed to do? Find the minimum uncovered element out of, before going into finding the minimum uncovered element, I'll have to go with the ticking procedure. So ticking procedure, tick the row with no assignment. Row number 3 does not have an assignment, tick it. So in the ticked row, look for a crossed zero. Tick that particular column. In the ticked column, look for an assignment. Tick the corresponding row. So two rows got ticked, one column got ticked. Draw a line from ticked column and unticked rows. So I get one vertical line, three horizontal lines. What is the total number of lines now? Four. How many assignments we have got? Four. So four assignments, four lines. My line drawing is correct. So once the line drawing is correct, identify the minimum uncovered element. Out of the uncovered elements, 14, 12, 14, 4, 12, 8, 6, 4, which is the minimum? 4 is the minimum, right? Minimum element is 4. Subtract that 4 from all the uncovered elements, and at the points of intersection at 8, at 19, at 11, add this 4. So the resultant will be 12, 0, 0, 7, 0, 0, 10, 8, 10, 0, 0, 8, 4, 2, 0, 23, 1, 0, 0, 5, 15, 5, 0, 0, 1. So this is the matrix that I've got after subtracting the minimum from all uncovered elements and adding at the points of intersection. Check whether all rows have zeros. Yes, all rows have zeros. Check whether all columns have zeros. Yes, all columns have zeros. So straight away we go with the assignment step. So we'll have a look at the assignment now. So the assignment matrix. So look at the first column. I have two zeros. Second column, 1 0. Third column, 3 zeros. Fourth column, 2 zeros. Fifth column, 3 zeros. Which is the column with minimum number of zeros? Second column. So in the second column, I make an assignment. Zeros in the same row have to be crossed off. So I'm remaining with two zeros in first column, two zeros in third column, two zeros in fourth column, and two zeros in fifth column. All columns have two zeros now. So in whichever order. So I'll go with the first column. I make an assignment in the same row or same column wherever I have a zero. I'll just cross it off. So now I'm remaining with two zeros in third column, two zeros in fourth column, and only one zero in fifth column. So now priority has to be given to fifth column. So I make an assignment in the fifth column. Any zeros in the same row, same column has to be crossed off. None of the zeros were available. So now I'm left out with two zeros in fourth column, third column, and two zeros in fourth column. So I go to third column, make an assignment, cross off the zeros in the same row, same column. I'm left out with only one zero in the fourth column. Make an assignment there. How many assignments did we get? 1, 2, 3, 4, and 5. 5 assignments we have got. How many we were supposed to get? 5. So all the assignments are obtained. So we have arrived at the solution. So the assignment calculation we'll see for the final solution. 1 is assigned to B, 2 is assigned to A, 3 is assigned to E, 4 is assigned to C, 5 is assigned to D. Now go back to the profit matrix. From the profit matrix, pick the values. 1 to B, 38, 2 to A, 40, 3 to E, 37, 4 to C, 41, 5 to D, 35. So when you add up all these values, I get 191. So in minimization case, I used to write it as total assignment cost. The same thing, we call it as optimal assignment value in maximization. So the optimal assignment value is rupees 191 with assignments 1 to B, 2 to A, 3 to E, 4 to C, and 5 to D. Right? Understood? Is the problem simple? Okay, fine. Now it is time to check yourself. Try it yourself problem. So find the optimal assignment value for the following problem with 5 jobs and 5 workers. The profit matrix is given below. What matrix is given? Profit matrix. So what type of problem is it? Maximization type. So you will have to solve this maximization type problem. And where are you supposed to write the answer? Post the answers in the comment section. Fine. Good. So the matrix is 11, 17, 8, 16, 20, 9, 7, 12, 6, 15, 13, 16, 15, 12, 16, 21, 24, 17, 28, 26, 14, 10, 12, 11, 15. Hope you will solve the problem and send it across in the comment section. Tomorrow evening, the solution will be posted on the classroom platform. Till then, have a nice time. Stay at home. Stay safe. Thank you.